be talking about some work with collaborators at UC Berkeley. In this work, we propose a method to edit 3D scenes, like this NeRF reconstruction of our live Frederick. And we want to do this with natural language instructions, like give him a mustache or as a bronze statue. If I wanted to perform these types of edits with traditional methods, I'd have to spend years learning how to use 3D software like Blender. And even then, editing a single scene can take hours of hard work. And so recently there's been a line of work aimed at NeRF editing, but these methods can only do certain types of edits, like local appearance changes or global stylus transfer. So in this work, we introduced Instruct-NeRF2NeRF, which can perform holistic edits using only an instruction of what to do, like give him a cowboy hat, and the model will figure out, based on the context of the scene, to put the cowboy hat on top of Frederick's head. These edits can be anything from local changes like give him a mustache to global changes like turn him into Batman. So our work is based largely on instruction-based 2D diffusion models. In our case, we use Instruct-Pix2Pix, which has two main benefits as a generative prior. One, it uses instructions, which allows for more control over the desired edit. And two, the model is image conditioned, meaning the output image will be consistent with the input image. When editing a pre-existing 3D scene, this image conditioning is key, as it allows the system to be faithful to the original content in the scene. So naively, the first approach that we thought of was to simply take all the input images used to reconstruct our NeRF, edit them independently with Instruct-Pix2Pix, and then reconstruct our NeRF afterwards on all these edited images. But this fails. By looking at the scene, we can see that because the edited images are no longer 3D consistent, it produces various floaters and artifacts. So we need to make sure that the edited images are 3D consistent. So instead of editing our collection of images once and subsequently optimizing the NeRF on the set of edited images, we can perform this process iteratively, where we gradually optimize the NeRF given a set of continuously evolving images. These edited images are created by running the diffusion model, just as before, but now we create a feedback loop by propagating information from our current estimate of the edited NeRF back into the diffusion model, so that our edited images become gradually more and more consistent. And so we achieve this by a method that we call iterative dataset update, where given a NeRF reconstruction and the set of training images, we can continue optimizing the NeRF normally, sampling rays randomly from all training groups. Then every few iterations, we edit an image in our dataset. So Instruct-Pix2Pix takes in a few input signals. First, it takes in a conditioning image, and we set this to be the original input image. Second, it takes in a text instruction, which we already have. And finally, it takes in a noisy input image that is gradually denoised to an estimate of the edited image. So in order to propagate information about the current state of the NeRF, instead of starting with an image of full noise, we can randomly select a training camera and get a render of our current NeRF scene. We can then partially noise this image, and then use Instruct-Pix2Pix to iteratively denoise the input to be a clean estimate of the edited image. We can then replace the current NeRF dataset image with this new edited image, and continue to optimize the NeRF. We repeat this replacement process every few iterations while simultaneously optimizing our NeRF, and this iterative process allows for the NeRF to gradually converge to the final NeRF. So here we show the training of the NeRF as it progresses towards the edit. Over time, the edit becomes much stronger and more 3D consistent. And here's the final result. So we show we are able to edit large-scale, real-world scenes. We can perform various global edits, such as changing the time of day and adding this nice sunset. We can also change the climate and turn the scene into a desert. And we can also make it look stormy. And I just want to highlight how hard it would be to make these types of edits on a traditional scene or even on a NeRF. If I wanted to change, this would require hours of work to adjust the background or change the style of the tree. And here, all this is happening automatically with just a single text instruction. And all the while, we maintain high quality and 3D consistency. We can also perform edits on 360 captures of objects. Here, we can refer to the object we want to change, and the model will figure out where the bear is and how to change it. And it will leave the rest of the scene the same. We can also edit humans. We can change the appearance by turning him into a marble or a bronze statue, or we can edit the geometry of the scene by putting a firefighter hat on him or giving him some clown hair. A cool feature of the system is that it can control the strength of an edit by changing the guidance scales of Instruct-Pix2Pix, making the scene more or less like a desert. And so to wrap up, here are just some of the many cool edits people have been making with our code online, so definitely go try it out. And thanks everyone for listening.